Here are the instructions for problem 3 of the first exam for ENMA 603. What I would like you to do is I would like you to work through the simplex, and I want it to be done in algebraic form, step by step, and solve the following problem. So each person in the class will be assigned a different problem, so I would like you to go to the template that has each person's name and the problem that they will be working. So it's going to be a maximization problem. So let's assume that you're the first person in the class. In this list, your problem will be maximize z equals 3x1 plus 4x2 plus 5x3, subject to these three constraints. So what I would like you to do is write out the linear programming formulation in standard form. And I'll give you an example of that. The problem that I'm going to work for you guys is the problem that I had posted in the book chapter that was posted online. So the problem I'm going to be solving for you has this form: maximize z equals 6x1 plus 1x2 plus 5x3, subject to these three constraints. So I would like you to write it in this form. So let's suppose that this was the document that you were working on. I'm just going to copy and paste, but I want you to actually write it out. So your problem would be maximize z, whatever the objective function is assigned to you, subject to these three constraints, and x1, x2, and x3 greater than or equal to 0. Then what I want you to do is I want you to show the simplex method, and I want you to record the values of x1, x2, and x3 at each iteration. So I haven't worked the simplex for this problem, but I want you to actually go in and work the simplex method for the model formulation. And then what I want you to do after you solve the problem using the simplex method is I want you to go in and calculate all the basic feasible solutions for the polytope. So I have provided you an Excel spreadsheet that will do that. It has all of the plane intersections, and you simply just plug in the coefficients for the model. So you can see in this particular case that plane A is 6, 2, 3, plane B is 6, negative 1, 3, plane C is negative 3, negative 1, 3, and then the values that it has to be less than. So this template will give you the intersection points for the 8 basic feasible solutions. So what I would like you to do is list each one of these intersection points. So just type in something like vertex 1, and vertex 1 is where planes, let's see what 3 planes come together for vertex 1. You could say plane ABC is vertex 1, so just type in ABC and then plug in what that coordinate is, which is 1, 6, and 4. So the x value is 1, the y value is 6, the z value is 4. And do this for all 8 basic feasible solutions, basically the corner point of the polytope. So you should have 8 of these. So vertex 1, vertex 2, all the way down to vertex 8. And whatever these values are for your particular problem, just list them. Because what I want you to see from this, from solving this problem, is I want you to see how the simplex method relates to the basic feasible solutions, or the corner point solutions. Okay. Now that you have done that, what I would like you to do is I would like you to use the software I have provided called GraphCalc, and I want you to create a polytope. Okay. Now, I have a standard format that I want you to use to create these polytopes. And the way that you will load the settings into GraphCalc is you will click on File, Settings, and Load Settings File. And I have provided you with a file called ENMA 603 Exam 1's Exam 1 Settings.gcl. I want you to open it. And what this does is it goes in and it loads it'll load any equations that you have in GraphCalc, but more importantly, what it does is it loads these standard colors in for you. So any settings that you have changed in GraphCalc, you could go to File, Settings, and save those settings as a GCL file, and then you're able to replicate any results. Okay, so I have already inputted the three planes into GraphCalc. So to rotate GraphCalc, or this polytope around the z-axis, you can simply hit the control button and the left mouse button and move the mouse, and it will rotate around just like this. Or if you hit the control button and the right mouse button, you can actually pan this and move it around. Or you can just hit plus or minus, or use the middle button, or the middle roller button on your mouse to zoom in and zoom out. Okay, so that's how you can manipulate this this graph using GraphCalc. All right, so let's move this down just a little bit, and I want you to okay. Now, what I have in this particular case, I just realized, is that I actually don't have the equation for my model. So I'm going to go ahead and input this this equation in. So when I loaded the settings, I had another equation in. So let me go ahead and load this. So for the first constraint, I'm going to have 30 minus 6x minus 2y divided by 3. So you have to use x, y, and z coordinates. x1, x2, and x3 will not work. So you see how I basically rewrite this constraint here in terms of the x3 variable or the z variable. So it's simply going to be 30 minus 6x1 minus 2xy, or 2x2, divided by 3. So I want to have x3 is equal to, or z is equal to, this equation. So it has to be written in a standard form. So the second one is 12 minus 6x minus, or should be plus y, divided by 3. This one is 3 plus 3x plus y divided by 3. And let me go ahead and write the objective function. Notice the objective function is a different color, but I'm going to go ahead and write this 6x minus y divided by 5. But I'm not going to graph that yet. Okay, I'm just going to hit apply, and let me go in and change. Let's see, will 6 work? Yeah, that's pretty good. Basically, I just changed the range for my x and y coordinates just to get a better image. So I'm going to move this around. Let me maximize it. So you can see how I have this polytope now. So like I said, control left allows you to pan this and just move your mouse around with the right button just to do a free rotate, and then control left button allows you to rotate around the z-axis. Okay, so let me get this a good angle. I think this is good. Now what I'm going to do is I'm going to do a screen capture of this particular file. So let me see what I have here in the text. Yeah, so I want to do a screen capture that looks something like this. So the way that I can do this is I have posted another software. It's called MWSnap. So you can download this and install it. This allows you to take screen captures. So I'm going to click on any rectangular area, snap to any area, and then I'm going to move the cursor up here, upper left-hand corner, pull it down, and maybe there we go. I have taken a screen capture.